Hi and welcome to my new video. Today I would like to present a topic that I already covered in the blog, but at that time I covered it in the context of Apache Airflow. And today I would like to do the same exercise, but with Azure Data Factory Orchestrator. And the topic will be about data orchestration pattern that you can use in your data processing pipelines. So on my screen, I already connected to my Azure Data Factory instance, and I will create the first pipeline where I will show you six different patterns. So the first pattern is called sequence, and the idea is to execute the jobs or the data processing steps one after another in a sequence. So obviously, as an example, we could have a kind of job that will copy data maybe from an on-premise environment, and we can also it will copy this data from an on-premise to the cloud storage, and later we will have maybe a PySpark job that will process this data in a sequence, write it to some other place, and maybe later we could also trigger an Azure function to do some very small and cheap operation. So as you can see, the idea of this pattern is to execute these steps in a sequence, and it's the specificity because from this sequential execution you can deduce that each step depends on the outcome of the previous one. So the second pattern is called parallel split, and unlike the previous one, here we will create two or more sequences. So we have our sequence pattern, and now if we would like to convert it into the parallel split, we should add one or multiple different branches. So the specificity of this pattern is that these branches are executed in parallel, so there is no conditional execution of them. So here we can see that we have our task that brings some data from the on-premise to the cloud. Later we have the first branch that runs that Databricks job, followed by some Azure function, and the second parallel branch is about the big job. So here we could imagine that we have a data migration scenario, and we want to rewrite this big job into new technologies like using Databricks and Azure function. But in order to keep the data consistent and safe for a while before the migration is validated, we will keep both running, and maybe this first branch will generate the data to some staging area or to some temporary area that will not be directly exposed to the users, but that will be exposed only to some technical users who will validate this data against before switching on and terminating the migration. So that was for the parallel split. Now I would say it's not the exact opposite, but it's complementary. A complementary pattern for this parallel split is called synchronization. So in this synchronization pattern, we still have some branches, but at the end, we have one task that conciliates, that takes the that executes when all these branches terminate. So here you can see that we have our new pipeline, new candidate for the production, and our old pipeline with peak. So what we could imagine here by using this synchronization pattern is to have maybe another Databricks job that will, let me maybe change it a bit. Okay, so now we can have another Databricks job that will wait this branch and this branch to terminate and run maybe a kind of, we can imagine data comparison that will assert whether the production candidate performs as well, as good as our obsolete pipeline. And of course, we could eventually do some small and cheap operation later with Azure function about the output generated by the Databricks. But anyway, that's the whole idea of the synchronization. So we have two or multiple branches that need to be synchronized at the end, because we have one task which needs all these branches to terminate, all the output generated by these branches to be available before running. You saw so far that we moved from the sequential pattern to some multiple parallel execution patterns where we can have multiple jobs depending on the same parent, and we can also have multiple parents providing some data to one child task. Now we can do something a bit more complicated, because we can use the pattern which is called exclusive choice. And this exclusive choice, we in Azure Data Factory, we rely on the if condition. So we could imagine our copy data that will, so maybe remove all this. So we have our copy data that brings the dataset from on-premise to the cloud. And later we have two conditions to define. So I will say that for the first condition, we will process the data in this new pipeline. Remember, with Databricks PySpark and followed by some Azure functions. So that's for the new pipeline, new candidate. Yes, so you can see that we have two activities like that. And if some condition evaluates to false, we will simply run our old peak job. And here we could imagine that this will not behave the same like previously with parallel split. We could imagine that this if condition will trigger the new pipeline for the new dataset, because maybe we changed something or adapted the dataset to some new modern technologies. And otherwise, if some condition is false, it will simply run our old peak job based on the old execution context. So unlike two previous patterns, you see that it doesn't execute anything in parallel. It executes one or another branch. So that was for the fourth pattern. The next pattern is called a data sensor. So it's quite obvious to implement in Apache Airflow, because its API directly provides the methods to listen for some events to happen. But we can also simulate it in Data Factory with the until activity. So inside we can define some sub pipeline where we will listen, or we will wait for something to happen. So we could, for example, use here a lookup activity that will try to find some files that we will later process in our, so we will bring these files to the cloud, and later we will process them with some PySpark job. So the idea here is to prevent against some unexpected things. So because you can imagine that the copy will, even though you trigger the copy every day at 3 a.m., it will not necessarily be ready every day at 3 a.m. because this copy is made available by other team or maybe by other company, meaning that you are dependent on them and you cannot assume that the data will be always there, or the data that will be always there will be complete and ready for processing. So that's the reason it's always good to use this kind of the sensors to wait for something to happen, like the data availability. And the data availability can be expressed in different manners. It can be, for example, Apache Spark success files that you certainly met in your Apache Spark adventure, or it can be, for example, a kind of a metadata file listing all available files for processing for a given hour, and so forth and so on. And this until activity can wait for this file to be created. And the final pattern is a bit similar to what we have seen before with the parallel split, except that it will execute one or another branch depending on the outcome of the task. So here you can imagine that we are copying some data from on-premise to the cloud, and later we have two Databricks jobs, one running with PySpark and another running with Scala Java API. And the point is that what you've seen so far is the example of the parallel split, because we have one common root that will execute two parallel tasks. And the point with the final pattern, which I called outcome dependent execution, is that you will run this or this task only if this one succeeds or fails. How to do that in Data Factory? So you have to change the conditions in the generated code, and you can see that for both Databricks jobs you have the dependency condition. So we can imagine that we will execute PySpark whenever this copy from the on-premise to the cloud succeeds, and that we will execute the Java Scala API job when this copy fails, maybe because we have some fallback mechanism which is implemented with this Spark API. So I will save it, and later you can deploy the template and move it to your production environment. So in this video you have discovered 6 different patterns that you can use in Azure Data Factory, but also in other data orchestrator framework, because they are quite agnostic. It was Bartosz Konieczny from waitingforcode.com. Thanks for watching.